And then the last thing to talk about is the different detectors. Well, not the last thing, but before we click and get an image, talking about the different detectors. The PMTs, you have PMT1 and PMT2. Those are sort of standard photomultiplier tubes. It's the classic detector that has been on confocals for decades. It's probably exactly what was on your Nikon many years ago. Just a standard multi-alkali PMT. They work great, they're very robust, but it is older technology. They aren't the most sensitive detectors out there. They do have some background noise, things like that. But I mean, they still work great for most confocal imaging.
I luckily usually have lots of signal because fruit fly brains, for whatever reason, produce GFP in incredibly
Really
large
well.
percentages.
So yeah, if you have bright signals, you'll have no problem at all using the PMT.
The cell culture people, they're always bummed because they never have enough signal.
Right. And so here, other thing with those is they're amplifying the signal through a cascade of diodes. By setting the voltage between those diodes, we can determine how much we amplify our signal. And so that's what this gain number here is actually voltage steps in the PMT. And typical values for that are in the 700 to 800 volt range. That's kind of the default setting here. So I'm trying to, if you just want to click on that 0 or grab that slider and set the gain on that one to about 700. And then if we click, and I can probably click live here. If we click the live button down in the bottom left, it should
Yep, I'm seeing cells.
Give us a live image there. So I'm going to stop that so we're not just sitting here, because the live button will just constantly scan and scan and scan the sample. And if you do that for hours and hours, or depending on how photosensitive your dyes are, you can bleach your sample with higher laser powers and running it for longer.
That'll be one of my first lessons is bleach the sample, or, you know, like keep taking pictures and just setting the power at high and low and just letting the student figure out what happens.
Yep.
And that'll be just sort of the fun thing about non-precious samples is like, go ahead and figure out what destroys it so you don't do it in the future.
Right. And then this slider bar along that left-hand side, you can actually adjust the lookup table. If you drag that down, it will get brighter. If you drag it back up, you can sort of see the full range of the data that you're collecting. There's also a reset button.
Okay, so we did reset for the LUT and then auto scale for the LUT. Stack auto scale, oh, that's for a whole stack of them?
If you do, yeah, if you have the whole stack, it'll auto scale every plane in the stack the same, but it will pick out the brightest plane as the sort of the top of the LUT.
Right, okay, cool. All right.
And then the bottom button there will give you a histogram if you want to see the histogram of intensity values to help you set up sort of the exposure levels. The top button, so actually turn on, let's do, what was that?
This is a more traditional camera type of,
yep.
Right.
And so
I have a peak here. So if I move the darkness beyond the peak, we get nothing, right? Or actually it does still does something cool. But yeah, you generally moving this top one down. Okay.
Click the log button in the top left. Nope, sorry, down on the histogram, the top left of the right there. That just changes the display of the histogram so that you can actually see that left edge is now a log scale. So those shortest little peaks are a single intensity count.
Okay.
Where in the linear view, you don't actually see them because they're so dim. They just don't fit on that scale.
Okay. Log meaning logarithmic?
Yes.
Okay.
So we're actually not even using half of the like dynamic range we could be for this sample, it looks like. So we could go brighter. Other thing is click the top button on that column above the LUT, the very top one up there. Yep, click that once. And that will change the lookup table to be, to show you over and under exposure. So pixels that are blue are over the exposure of where you've set the top of your lookup table. Most people use this by resetting the LUT to the full range. And then they can adjust their gain and laser power to where you have pixels that are close to that white where it's not saturated, but you're using the full range of the system. But you don't have any blue pixels because blue pixels are overexposed and you can't quantify them.
Okay.
So here we're seeing some blue pixels, but that's only because we've scaled the LUT down. If we reset that to full range, then we shouldn't see any blue pixels at all. And we could actually either turn the detector gain higher or the laser power higher if we wanted to fill up more of that histogram. So yeah.
Okay. Awesome.
So I would say reset it like that and then click the live button. And then actually either adjust the gain or the laser power to get sort of these brightest pixels up. You don't want them at 255, but you can certainly go. You could probably go closer to 10 on the laser power.
All right. I'm sort of bouncing around 10, watching that top.
Yep. So there are a couple of pixels now out close, 1 pixel, maybe 2, out towards saturation. That should be fine. The other thing is move up and down through the Z-stack and just see if there's any areas that are going to be much brighter is the other thing that's really nice to do.
I'm also only at 10x, which is why
Yep.
I just went right through the sample. Okay. Nope, I just was happened to be in the middle of the sample. All right.
Oh, perfect. But yeah, I usually either use the histogram or this sort of colored lookup table to compare and just make sure you don't have pixels that are fully saturated, especially if you want to do intensity measurements later. If you hit 255, you don't know if you're actually at 255 or if you're up at 1,000. Like once it's saturated, you just don't know.
Okay. Yeah, it's funny you're a microscopist and I'm with other microscopists that are always concerned about this. And then the other teachers are also tissue culture and they cared about intensity. It's funny with my work, the cell bodies were always so bright. We didn't care about intensity. We wanted to see where was the expression. So we cared about the neural projections. So we would crank everything up to see those, and then the cell bodies would just be so bright and we would just ignore them.
Which is completely fine. You want the structures that you're interested in to not be overexposed.
Right.
I do try to clarify that most of the time. Yeah, if you're looking at dendrites from a neuron, you can blow out the cell body as long as what you are quantifying is not overexposed, you're fine. The other thing is if you're not quantifying intensity, if you're just measuring distances and things,
Right.
doesn't matter then either.
Okay. What do you want to do next?
So that's setting that up. Next thing, let's actually switch, and instead of that PMT, let's do the exact same window, exact same position, but use that HyD 3 instead. So click that on, yep, turn the bottom one on, the top one off, and then move that position over to there.
Where were you at 500 to 550?
Yep. And yeah, as you bump them together, you can see you can actually just push the other ones out of the way. You don't have to match it exactly, but.
Would it let you, and then do I do live again if I want it green?
Yeah, if you just double clicked on green, the circle's green, hit live, and it will come up as green now. If you want to change one after acquisition, you just double click on that lookup slider where it goes from black to green or black to red there, like right on the actual color. Yep, double click right there and you can change it afterwards.
Oh, okay, gotcha.
But
so why does this PMT have so many more lines with it?
Well, so, right. There are some big differences in these two. First thing you'll notice here is if you actually click that lookup table one more time, up at the top, yes, click that once. Now it's coloring everything that's overexposed. Whoops, go back to where it was all mostly green. There. If you look, those brightest pixels now, we have a lot more blue. And if you look at the histogram, there is a bigger spike out at 255. We are overexposing things a little bit.
Right.
So I would turn the laser power back down again, just a little bit, so we're not overexposing. Other thing is you see discrete spikes, which is really unusual for a histogram like this, where we're going from 0 to 255 on the intensity scale, but we have spikes spaced, I don't know if that's 5 or 10 units apart, but there are very discrete spikes in our sample. Those are actually photons. So that peak right here is completely black, 0 photons, 1 photon, 2 photons, 3 photons, 4 photons, and across. So this is a photon counting detector. It's so sensitive, it's actually counting photons individually.
Whoa, okay.
The gain on it is not adjusting any voltage or anything on the detector itself. It's actually a digital scaling factor of 1 photon equals how many intensity units. And so if instead of a gain of 100 here, if we type in a gain of 50 instead, which again, mine's going a little slow.
Want me to do it?
I can probably get it here.
We both did it.
I'll let you do it.
So now is it 2 photons for 1?
So it's not a direct correlation like that, but the spikes will be spaced half as far apart because we halved the gain. So if you hit live now, you'll see all of those spikes. There should still be spikes, but they'll be spaced a lot closer together.
Okay. I also turned down the laser from 10 to 6.
Yep, but if you could adjust it while it's live if you want to, and actually watch the changes live. The laser power is not going to change the spacing of the spikes because it's going to change the number of photons in each pixel, but it's not going to change that spacing of converting intensity to, or converting photon numbers to intensity.
Okay.
So the other thing with this detector using the PMT, looking at that image, a whole large portion of this image is green. This green color is actually 0 intensity units. So on the PMT, we did not get any pixels that came back as 0 intensity. It has a background count where the lowest intensity you measure with a PMT, even if it wasn't hit by a single photon, is usually in the 2 to 3 intensity unit range at the voltage we were running it at. There's always just baseline intensity coming off of it. These HyDs are so low noise that you can actually see a majority of that image is 0. Like we're counting photons, it did not detect a single photon in the time it was on that pixel.
Interesting.
So just the noise floor on these is pretty incredible.
That is incredible.
So
HyD was it set for red because that's the one that it's the most useful with, or why would you do PMTs for UV and GFP and then HyD for red?
So the first one, the PMT in position 1, is usually there because a lot of people are using DAPI to label nuclei, and that's always sort of going to be in that first UV position. DAPI or Huxt or whatever you're using is so bright, there's no need for a HyD in that position.
Okay.
The positions 2 versus 3, either one could be either. There's not really a purpose for putting it in one or the other. The HyD is basically going to be better for whatever you're measuring. It is possible to use that HyD for green and red. You can have it shift positions between sequences. It has to measure the green image and then switch around and measure the red image. But it would be just like switching a filter wheel on a wide field system.
That's what my Nikon was. Yeah, it would always switch between the two.
Right. So here we can do simultaneous, where we can actually use all 3 detectors at exactly the same time with 3 different lasers.
Wow.
All done together. But then you're limited to only having the one HyD detector.
Right.
But if you do, you can set it up to be switching and use the HyD for as many channels as you want. It's a little bit slower, but it is possible if you have really dim signal that actually needs it. Because the PMTs always have that kind of inherent background, there is a offset on them. So you can see if we turn one of those back on, there's an offset value here. If you put in like -0.1 or -0.2 there, it will actually get you to a completely black background like this image. So all it's doing is just subtracting intensity off of the bottom of the image. It's just like sort of dragging the bottom of that lookup table up a little bit. It's just chopping off the dim stuff. If you go too far, you actually lose real signal. So you do want to be careful with that, but it can get you a black background image like this. Because the HyDs have so little noise, they don't even offer the offset. It's just not a function available with them.
So if I was actually trying to get neural projections for a 3D image, the HyD would be probably much better for getting little dim projections. Yep,
it would probably work a lot better. Other thing is it has some other modes that it can run in. So that standard right at the end of it, if you bring that down, let's see.
Looks like you have counting and bright R.
Yep. So counting mode, it actually correlates the photon counts to the intensity saved in the image. So it gets rid of your gain scaling factor. And if we click live, the whole image is actually going to get dimmer because right previously we were spreading out those photons over the whole histogram. Now, if I hover the mouse over the image, the intensity units you see down at the bottom right here, those correspond to the number of photons that were detected. So in this pixel I'm on right now, if it updates, it still says 0 for me. I'm not sure what you're seeing.
The mouse isn't doing much, but I think it's showing stuff down at the bottom.
Yeah, down at the bottom, it's saying intensity is something for the pixel that I'm hovering over.
Gotcha. Okay.
Which 110. That means in that pixel, it detected 110 photons.
Okay.
So there's a direct correlation between photon numbers and intensity. The PMTs, they can't actually count photons. The intensity is related to number of photons, but there is no specific number that can be matched. And then if you're not trying to do any quantification, we have 2 images here because we actually had 2 detectors on. So I just turned the PMT off to get rid of one of those images. And actually we want, let's go to bright R mode, which, if you want to, oh, I can get it now.
Oh, there you go.
Bright R and then hit live. Bright R mode is basically does a non-linear lookup of the number of photons that are measured is no longer linear proportional to the intensity in the final image. It's kind of, if you know what gamma adjustment is on the wide field side, similar to that, or HDR imaging, high dynamic range imaging on like cameras. Yep. It's doing that to the image to make dim things brighter and bright things dimmer. Cannot be used for any quantification, but is really good for making pretty pictures.
Okay, very interesting. Yeah, that's that was the game we did, was get the pretty picture.
So if you just need the pretty picture, you can absolutely use that mode. But if you want to do any quantification at all, it's a big no-no.
Right.
So, and then if we switch, let's get out of this funny color lookup table, because with the green and blue, it's really hard to see. And then one more click up there will give you black and white, and then a third click will get you back to the color that you had set.
Oh, I see. Okay. All right, cool.
And so you can probably see these kind of finer structures, maybe a little bit brighter in the bright R mode than they were. I'd probably have them do the PMT versus the HyD in standard mode first.
Okay.
Because that has fairly big differences on its own, and then you could see if they can tell if there's a difference in the bright R mode. Bright R mode gets used very rarely, and I think it is kind of a Leica specific mode. But the difference in the PMT and the HyD, like HyD is specific to Leica, but most of the competitors have some type of better detector than a PMT now. Whether it's, a lot of them have GASP PMTs or something else that's just a little more sensitive than the standard PMT.
Okay. I assume the PMTs are cheaper, so we put 2 cheap ones on and 1 expensive?
Absolutely.
Okay.
So yeah, I mean, that's the real reason why you only have one HyD is the cost. The positioning, there are 5 positions on the system. So if you wanted to add more, it is possible to add additional detectors. The middle detector must be a PMT in that
schematic that you showed.
In that schematic that I showed you. But with 3 detectors, you can actually put them in any order. Because as it goes 1, 2, 3, 4, 5, 3 must be a PMT, but you could do like 1 and 4 as HyDs, or you could do 1 and 2 as HyDs and have 3 be the last one, or you could start with 3 and have 4 and 5 be high, like with 3 detectors, there's no restriction on the order. It's just
right, because it's a triangle. There's only
how
3.
you arrange them, right? If you get up to 5 detectors, then that middle one always has to be a PMT, and the others can be whatever you want. So there's one sort of, and it's just the physical size of the detectors. It won't fit in that one position is the only real restriction.
Okay.
So I'm going to get us back to standard if I can. Maybe you want to switch us back to standard mode.
Sure, I'll do it. All right, so our standard there, HyD. That's cool. This is great.
And it's the HyD. If it gets too much light, it will actually shut itself off. And you'll get, instead of the little green circle to the left of the shape, it'll actually have a little red warning triangle with an exclamation point in it.
Okay. Oh, all right.
So too much light will damage them. That safety circuitry cuts them off very quickly, but it still like can pick up a tiny bit of damage before it shuts off. So if it shuts itself off hundreds and hundreds of times, eventually it will fail. It is pretty safe that it will turn itself off quickly enough, but we have seen people that just blast them and blast them and blast them, and they don't.
Are they blasting it with the laser power up here, or with just leaving the gain too high?
So the amount of gain doesn't actually matter at all. It's the laser power, or overlapping it. Like you don't want to position that window underneath the laser if you can help it. Sometimes that will. The low angle dichroics are actually really good at eliminating laser, but if you have really like big refractive index mismatch or something, you can get some reflection getting back to the detectors.
Gotcha. Right. Okay.
So the beam splitter, that auto select checkbox, I turned it off to show you what beam splitters are available. I would always just leave it on the auto select, because then it will automatically pick the best one for you, and you don't even have to think about what beam splitter you're using.